Students, myself is Dr. Kapil Ori, working as lecturer in Civil Engineering Department at Maths and Polytechnic College, Jalandhar City. मैंने पंजाब के डिप्लोमा स्टूडेंट्स को फ्लूइड्स मैकेनिक्स सब्जेक्ट पढ़ाना है जिसका सब्जेक्ट कोड है 765। इस रिप्रेजेंटेशन में हम पहला चैप्टर है इंट्रोडक्शन। तो स्टूडेंट्स इंट्रोडक्शन में पढ़ना है what is fluid mechanics and what is hydraulics. So fluid mechanics क्या है? The branch of mechanics that deals with the properties of gases and liquids is called fluid mechanics. The term fluid in everyday language typically refers only to liquids. But in terms of physics, fluid describes any liquid or gas that conforms to the shape of the container. Fluid mechanics is thus the study of gases and liquids at rest or in motion. Study of the study of the behavior of stationary fluid is called fluid mechanics and fluid dynamics. And fluid dynamics is the study of the behavior of moving or flowing fluids. Fluid kinematics deals with the study of kinematic quantities such as velocity and acceleration. Fluid dynamics is further divided into hydrodynamics and aerodynamics. Hydrodynamics is the study of water flow and aerodynamics is the study of air flow. Now, what is hydraulics? Hydraulics क्या है? It is defined as that portion of subject which deals with water, at rest or in motion. It derives from the Greek word hydra, which means water. The applied science based on the results obtained from the laboratory experiments is referred as hydraulics. The results obtained from experimental analysis are usually reduced to empirical formula which have very limited use. Scope of fluid mechanics. The knowledge of fluid mechanics is required. Number one, to understand the behavior of fluid under all directions at rest or in motion. Next, for fluid pollution control. Then next, for the design of ships. Then next, for flow classification and flow analysis in pipes, open channels, etc. Next, to determine the fluid pressure distribution on hydraulic structures like dams, spillways, etc. Then next, for working of a hydraulic pump and compressor. Next is what is fluid? Fluid is a substance which is capable of flowing, and deforms continuously under the action of shearing stress. So a shear force, what is shear stress? A shear force is the component of the force which is tangential to a fluid surface. Then fluids may be divided into three types. Number one, liquids, vapors and gas. Liquids क्या है? A liquid is a fluid which has high specific mass or mass density and a free surface. Means at free surface, liquid is at rest and not in motion. It possesses a definite volume and is considered as incompressible. Vapors. Vapors are gas having high temperature and pressure very near to the liquid state. For example, steam, ammonia. gas. A gas is a fluid which has very low specific mass. It is readily compressible and possesses no definite volume. So this is the difference between liquids and gases. So in this difference, you have to study the difference between liquid and gases between these properties: specific mass, compressible property, free surface, molecular spacing, volume, force of attraction, fluidity, and storage. So liquids have high specific mass as compared to gases. Liquids are highly are incompressible as compared to gases, which are readily compressible. Liquids has free surface. Gases do not have free surface. Molecules are closely spaced. They are not closely spaced. They are at far distance from each other. Liquids have fixed volume. Gases do not have fixed volume. And forces of attraction. The force of attraction in liquids is less as compared to solids and is more as compared to gases. Gases have a very weak forces of attraction between the molecules. Fluidity flows from higher to lower level, flows in all directions. For storage, cannot be stored without container. Need closed container for storage. Next is characteristics of fluid. Following are the characteristics of a fluid. Fluids have certain characteristics that define them a fluid. For example, fluids do not have a definite shape of their own. Fluids have the ability to flow between the particles of liquid and, and gases are free to move. Uh, Fluids have the ability to flow because the particles of liquid and gases are free to move about. Fluid shows resistance whenever two layers slides over each other, and this characteristic is called as viscosity. A fluid increases its pressure against compression, trying to retain its volume, and this characteristic is called compressibility. Now, types of fluids. Fluids are classified as ideal fluids, real fluids, Newtonian fluids, non-Newtonian fluids, and ideal plastic fluids. So see this graph between shear stress and velocity gradient. And this graph shows the variation of the fluids depending upon the shear stress and velocity gradient. So number one is what are ideal fluids? Fluids which have no viscosity and surface tension are called ideal fluids or perfect fluids. They are incompressible. In such cases, only pressure forces exist whether the fluids are at rest or in motion. It is absolutely frictionless and have very low viscosity may be considered ideal. For example, air, water, etc. Such fluids do not exist in nature and are therefore only imaginary fluids. But are real fluids? Fluids which possess the properties such as viscosity, surface tension, and compressibility are referred as real or practical fluids. Such fluids are actually available in nature. These fluids offer a certain amount of resistance as and when they are in motion. So Newtonian fluids क्या है? They are real fluids in which shear stress is directly proportional to the rate of shear strain. ठीक है? So this fluid follow Newton's law of viscosity. So this is the derivation of shear stress. This is derivation you can say, or you can say the relation between the shear stress and velocity gradient. So Fs denotes shear stress, dv by dy shows velocity gradient. So shear stress is proportional to the velocity gradient or rate of shear strain. So this is the result, and mu denotes the coefficient of viscosity. dy by dy shows velocity gradient, in which dv is equal to is equal to density difference between upper and lower edge. dy is equal to thickness of fluid. In the in the topic of viscosity in the next chapter, you can understand this derivation more clearly and elaborate. Non-Newtonian fluids. They are real fluids in which shear stress is not proportional to the rate of shear strain or velocity gradient, are known as non-Newtonian fluids. Ideoplastic fluids, they are fluids in which shear stress is more and is proportional to the rate of shear strain. So in the graph, it is clearly shown the relation between the shear stress and velocity gradient or rate of shear strain.